In this video, we're going to look primarily at the topic of grouping objects through the use of the ArrayList class, which is provided as part of the standard Java libraries. And this will provide an introduction to the idea of collecting objects together. We're going to be adding to some of the themes that we covered in the last chapter. In particular, abstraction will figure fairly heavily in this discussion, because we want to think about the idea of a collection as being an abstraction for the idea of storing potentially large numbers of objects together. And we want to hide away a lot of the details associated with how items are added to a collection, how they might be removed, and in particular how the collection is implemented internally, because we should be able to make use of some of the predefined classes available in the Java library without being too concerned about exactly how they're implemented. We'll also be extending our look at objects creating other objects and objects making method calls on each other. Many applications involve needing to store collections of things. Think, for instance, of the contacts list in your mobile phone. It stores a large number of entries, and you might not even know how many entries it's storing. Think also of social media. If you have an account on a social media platform, then you're probably following several people, and you probably have people following you as well. In a university, there's going to be a student record system with potentially tens of thousands of records or objects storing student data. Or finally, think of something like a music playlist, where you've got a list of music tracks that you're interested in and that you listen to from time to time. Now, a common feature of all these collections, and collections in general, is that the size of the collection, in other words, the number of items in the collection, varies over the course of its lifetime. So when you first sign up for a social media account, you're probably not following anybody and nobody is following you, so the collection is empty. Then gradually, as you start to follow people, the number of people that you're following increases and people start following you, and so the collection sizes vary. You might decide to stop following somebody, other people might decide to stop following you, so numbers can go down as well as up. Similarly, in a student record system, as one set of students graduates, then those student records are probably moved out of one collection into a different collection, an archive collection, and then a new set of records will be created for the next set of incoming students. So it's very common that we want to add items to a collection, we want to remove items from a collection. Now, some of the things to think about when we're considering how collections are used inside programs are things like, do I want to set a limit on the number of items that I can store in this collection? Do I want it to be limited or not? One reason for limiting the size of a collection may be to conserve space. One reason for not limiting the size of a collection might be that I simply don't want to have to think about removing items in order to make space for new ones as the collection increases in size. Another feature to think about is whether the items are ordered in some way. For instance, are they ordered alphabetically? Or in something like a contacts list in a phone, are they ordered in such a way that the people that I call or call me are nearer to the top of the list because they'll be quicker to find? So related to the ordering is a sense of when I want to look something up, how will I do that? Will I be scrolling through a list until I find it, or will I be putting in some search terms into a search bar in order to find it? And the order in which the items are stored in the collection can affect the efficiency or the speed in which I look up an item in a collection. Now we're going to explore collections in a practical way through an organizer for music files. We actually saw an example of an application that can play MP3 files in a previous video. So let's just revisit that to remind ourselves of what it is we're going to try to head towards. Here's the application. It's in a very simple form at the moment. We have simply 4 tracks stored in our music collection, and we've got various controls that allow us to play those tracks, pause them, resume them, stop playing the current track, and so on. So ultimately this is what we want to work towards, the idea of having a potentially arbitrarily long list of music track files that we want to play. How can we go about doing that? Well, at the heart of the application is going to be a class that is able to store the track details. If we take a look at the project that's given rise to that particular application, then we can see that there are very many classes that have been used to put that together. There's a class concerned with the GUI, there's a track concerned with reading data files off the disk that stores the audio files, there's a class that's concerned with storing details of an individual track, and the class we're going to particularly focus on is this class over here, which we've called Music Organizer. So for the rest of this video, we're not going to concern ourselves with the rest of the classes here. We're going to focus on the Music Organizer class because that's at the heart of the functionality that allows us to store multiple tracks, an arbitrary number of them, add new tracks, remove old tracks, and so on. So let's look in detail at this class and introduce some new features of Java that will support our ability to define that class. So these are the features that the first version of our Music Organizer project is going to support. We're going to be able to add the names of files, where each file contains a single track that we want to be able to play. We don't want to have a predefined limit for the number of tracks that we can store in our music system. We want the music system to know how many tracks are being stored. We want to be able to list out individual tracks to find out what's stored in there, and from time to time we might want to remove tracks from this collection of tracks. So let's explore the simplest functionality that this Music Organizer class is going to support, because that will then lead on to our understanding of the Java class from the Java class libraries that allows us to support exactly that functionality. So here's our class, Music Organizer, and I've created already an instance of that class. I can observe that it has 4 methods. One allows me to add a new file to the collection. That takes a string. I can find out how many files are currently stored within the collection. I can list out the name of one file, and in this case I need to pass in an integer value that somehow identifies to the Music Organizer object which particular file I'm interested in viewing, and then I can remove a file. And again, I pass in an integer value that tells the Music Organizer which particular file I want to remove. Now the significance of the name of these parameters, index, will become clearer as we look in detail about how the Music Organizer class has been implemented. But I can demonstrate that if I call getNumberOfFiles, this is a newly created Music Organizer object, so it currently stores no files. I can add the name of a file. For instance, that might be Matchbox Blues. And now when I get the number of files, it's storing one file. I can list file number 0, and Matchbox Blues is what's file number 0. I can add a second file, and now of course I would expect getNumberOfFiles to return 2. The Music Organizer class has been written by making use of one of the classes that's provided as part of the Java class libraries. And the class libraries contain many useful pre-written classes that mean that when we're creating a new program, we don't have to write everything from scratch. We'll often be in a situation where somebody has already written a class that does a lot of the heavy lifting work that we need to do for our program. And so we would typically make use of somebody else's class that's been provided in one of the class libraries. Now what we're seeing in action here is abstraction. We can often use somebody else's class without needing to know all the low-level detail of how it's actually been implemented. All we're primarily interested in is, does it support the functionality that we want? And in the case of the music organizer, the functionality we want is the ability to store multiple items in a collection. In other words, the names of audio files. We want to be able to remove items from the collection. We want to be able to find out how many items there are in the collection. We want to be able to list out what's in the collection, and so on. And fortunately for us, there are several classes already predefined that support exactly that functionality and more. Now Java calls its libraries packages, and we're going to be looking at classes from what's called the java.util package in this discussion and in future discussions associated with the material in chapter 4. So here's the fundamental source code of the music organizer class, or at least this is the definition of the single field that it has and the constructor to initialize that field. And there are a few features evident in this source code that are introducing new concepts associated with making use of class libraries. So the first one is the line right at the top of the source file. The line says import java.util.ArrayList. And that's our way of saying to the compiler, we're going to be making use of a class that we ourselves have not written, but is to be imported or accessed from the class library called the java.util package. So we're importing the ArrayList class that belongs in the java.util package. So what that does is it introduces into our program the name ArrayList, and whenever we use the word ArrayList, then the compiler knows that we're referring to one of these class library classes. How do we make use of that name ArrayList? Well, we can see in the definition of the single field in the music organizer class that it's named there. Now, although it looks slightly different from field definitions that we've seen before, this field definition has exactly the same structure as all of the others we've seen in classes like the ticket machine and the clock display. We have the word private, then we have the name of the type, then we have a variable name, and then we have a semicolon. What's different is the nature of the type. It's no longer a simple type like int or string. It's a more complex compound type, or what we actually call a generic type. So the type is ArrayList of string. In other words, what we're saying is we're defining the variable files to be something that can refer to an object of type ArrayList of string. In other words, the object that files will refer to will be an ArrayList object, and that ArrayList will be able to store string objects. The next step is obviously in the constructor to initialize that file's variable, and we do that by creating a new ArrayList object. So on the right hand side of the assignment statement, we say new, and then the type, which is a shorthand for ArrayList of string in this particular case. So we're creating a new ArrayList object and initializing the file's instance variable to refer to that ArrayList object. We'll say a little bit more about the type that we're creating there because it's a slight shorthand notation that's being used, and we'll explain what that is in a moment. So when we want to make use of a class from the java.util package, we first import it, and then we specify the type of collection we want, which is ArrayList. We specify the type of objects that we wish to store into the ArrayList, and we refer to that particular type designation as ArrayList of string. One thing I'll just mention is those of you that might have programmed in other programming languages might be aware of the word array, and it's very important to appreciate that an array list is not the same as an array. So if you talk about array lists, it's important to refer to them as array lists rather than array. Although array list has some connection to an array, we're not going to go into detail at the moment, and arrays and array lists are different things. So we noted that array list is what we call a generic type or a parameterized type. In other words, the name array list only tells half the story. When we use array list as a type, we also need to say what type of objects that array list is going to be storing. But because array lists are generic types, we're allowed to define array lists of person objects, of ticket machine objects, of string objects, whatever we want. So this is one of the powers of generic classes, is that we can customize them or adapt them to fit the particular requirements we have for storing particular types of objects. Now, an array list implements what we call list functionality. So it provides a set of methods that are common to lists, and they allow us to do things like add an item to the list, get an item from the list, find out what the size of the list is, and so on. And we'll see those methods in action shortly when we look at the source code of the methods of the music organizer class. So just to come back to how the new ArrayList statement looked inside the constructor of the music organizer, what we say is that creation of the ArrayList uses diamond notation, and that the diamond is a less than followed by a greater than symbol, and that says to the compiler, substitute in here the type of objects that the variable on the left hand side of the assignment has been declared to store. So we don't explicitly have to say I want a new array list of string. The compiler can infer from the declaration of the variable on the left hand side what type of objects are going to be stored in the array list, and the compiler can then make the necessary arrangements for that to happen. Now, in some older code you might see that full type spelled out as at the bottom of the slide. So some people will write new array list, and then inside the diamond angle brackets they'll write the type of objects to be stored inside the collection. In general, it's not necessary to write that extra piece of information. So if we're creating an ArrayList object and then we're going to store an arbitrary number of string objects into it, how's that going to look at runtime? What's the dynamic state of the program going to look like? What are the objects that are going to be in existence, and how are they related to one another? It's useful, therefore, to look at a typical object structure, a runtime object structure. We have at the top left-hand side our music organizer object. That music organizer object will have created an ArrayList object, and therefore its file's instance variable will refer to that ArrayList object. And then inside the ArrayList object will be references to all the string objects that we've stored into the ArrayList, and we'll see how to do that in a moment. So this ArrayList object is storing references to just 2 strings at the moment. Of course, as time goes on, we'll add more and more and more strings into our music organizer for all the tracks we're interested in, and the ArrayList will then accumulate all of those tracks. And in fact, what happens is it simply grows and expands in order to contain as many strings as we wish to store inside it. So there's an example where we've now got 3 rather than 2, but we could go on and on and on, adding 4, 5, 6, 1,000, 10,000, however many music tracks we want to store references to inside the array list. So an important feature of the collections that are defined and available from the java.util package are that they keep on increasing their capacity as necessary. We can go on and on and on, adding items into the collection within the limits of the machine that we happen to be running our program on, but there's no fixed size, there's no fixed limit to an array list or any of the other collections that we might be choosing to work with. And the array list keeps a private count, an internal record of how many items it's currently storing, and it provides an accessor method called size. Note that it's size rather than get size, that then returns a count of how many items it's currently storing. Now, an important point is that details of how this is all done, how an array list actually manages to store an arbitrary number of objects and just go on and on expanding, are completely hidden to us. And that actually doesn't matter. So an array list provides us with an abstraction. It provides us with functionality to allow items to be added, to be removed, for the count of items to be returned, and so on, without us needing to know the low-level detail of exactly how that's provided. So we're really seeing abstraction in action when we start making use of collection classes and library classes in general. So as noted before, there's no limit to the sort of array list that we might choose to create. So a student record system might have an array list of person. Our music organizer might ultimately keep an array list of track objects. If we move away from the idea of storing literal strings for files, we might want to break that down into a little bit more detail. We might be an organization that needs to know what the current time is at lots of different places around the world. So there's no reason why we shouldn't have an array list of clock display objects, each of which is storing the current time in London, in Paris, in Hong Kong, wherever that might be, and so on. Let's move on from the definition of the field and the constructor in the music organizer class and look at how we might write methods inside the music organizer in order to be able to start storing new track information in there, finding out how many items are stored in the collection, and so on. Here we have a definition of an add file method in the music organizer. As we saw in the project, the add file method takes a string parameter, and what that method does is it simply hands over that string that it receives to the add method of the ArrayList object. So here we're making an external method call to the object referred to via the files variable. We're calling the add method on an ArrayList, and we're passing as a parameter the string that we want to be stored into the ArrayList. So that's how we add a new item into an ArrayList. We call its add method, we pass it a parameter of the same type as the object is meant to be storing, and that ArrayList then arranges to place that new item in its next free location within the collection. If we want to find out how many files we're currently storing in the music organizer, we have a get number of files accessor method that returns an integer value. Now notice that whereas in previous classes we would have expected the get number of files method to be returning the value of a number of files variable, the music organizer class does not define a number of files variable. It does not keep a separate count of how many files are stored in the music organizer. And the reason for that is it doesn't need to. That information is available directly from the ArrayList object. So what the get number of files method does is it uses a process called delegation. And delegation means it can't answer the question itself, but it hands the question on to a different object to answer for it. So in this case, what the getNumberOfFiles method does is it asks the ArrayList object, what's your size? In other words, how many strings are you storing? And the result returned by the call to the size method of the ArrayList is then directly returned as the result of getNumberOfFiles. And this is a very common pattern that you'll see where one object makes use of another object in order to provide its functionality, and there's no need to store a separate count in the music organizer object itself. Now, one thing we need to be aware of when we're using an ArrayList class is that the ArrayList assigns index values or indices to the individual items that it's storing. So it gives the index 0 to the first item it stores, 1 to the second, 2 to the third, and so on. So it's important to appreciate that index values start at 0 rather than 1. And so we can ask the ArrayList to return a particular item that it's storing inside it by passing the appropriate index to it to ask it to then access that item and return it to us. Let's see how that might work in practice. So we saw in the demonstration of the project that the listFile method takes an integer index and it then returns the particular file name that's stored at that index. And you saw that I used the value 0 first of all for the very first item. So the listFile method is receiving an integer index, and the very first thing we do is actually make sure that that index that's been passed in is valid for the current state of the array list. For it to be valid, it must be a number in the range 0 to 1 less than the size of the collection. So because index values start at 0, if a collection contains, let's say, 3 items, the valid index values will be 0, 1, and 2. So the largest valid index value is 1 less than the size of the collection, which is 3. Similarly, if the list had 10 items in it, then the largest valid index would be 9, 1 less than 10. So we check that index value, and as long as it's both greater than or equal to 0 and strictly less than the size of the collection, the number of items in the collection, then we can pass that value into the get method of the array list, and it will return for us the particular string, in this case, that's stored at that index. And here we choose to store a reference to that string in a local variable called filename, so that the next step we can then print out the name of the file that was returned at the given index. Now, one thing worth thinking about is that if we're checking to see whether the index is valid, we might want to report to the caller of that method if they pass in, let's say, a negative value or a value that is greater than or equal to the size of the collection. We've chosen not to do that here for the sake of simplicity, but that's something that's always worth considering if we're making validity checks on parameter values. Now, if we were to remove an item from the collection, then what the collection does is it reorganizes itself and it always fills in the gap. So if we called the remove method on a collection storing 3 items and we pass the parameter 1 in as the index, then the item that was stored at index 2 would move into the gap and now occupy index 1. If there were an item at index 3, that would move into index 2, and so on. So all the items would be shifted down by 1 place so that there are no gaps left in the collection. And it's important to appreciate, therefore, that the index of a particular item in a collection may change depending upon whether new items are inserted somewhere other than the end of the list, or if items are removed from the collection. One thing that integer index values support are some useful abstractions. So we often want to say things like, well, give me the next item in the collection, or give me the previous item in the collection, or give me the first 3 items in the collection. And because we're using integer index values with an array list, and we have a current index, then the next item will be at index +1, and the previous item will be at index -1, or the index of the last value in the collection is always the size of the collection -1, because the index of the last one is always 1 less than the size of the collection. So it's worth bearing in mind that we can map abstractions like next, last, previous into manipulations of integer values. So we've begun to think about collections and how they might support us in the building of applications that require us to store arbitrary numbers of objects. And although our focus has been on storing string objects in this particular case, we can think beyond strings and say, well, an array list, given an appropriate type parameter, can be used to store any type of object that we choose. Array list of student objects, array list of ticket machine objects, and so on. So what we're doing is we're making use of tried and tested classes that other people have written and then made available through the Java class libraries in order to support the more rapid development of our programs. We don't have to write everything from scratch. We've noted that ArrayList is what's called a parameterized or generic type. In other words, whenever we talk about an array list for a specific application, we're usually talking about an array list of some particular type, such as array list of string. The main ArrayList methods to become familiar with are methods like add and remove for adding and removing items, get in order to retrieve an item at a particular index, and size to find out how big the collection is. And each item in an array list has an associated index value, although those index values might change as items are removed or further items are added at positions other than the last position in the array list.